My dear student, welcome to School of Fundamental Sciences, SOFS. I deliver some fundamental concepts of physics, chemistry and mathematics for JEE Main and JEE Advanced. It will give me great pleasure if you enjoy this concept. So let us start calculus for physics second part. RC04, I will give you the idea of instantaneous velocity. The instantaneous velocity of a particle at a point of its path or at an instant of time t is called the instantaneous velocity. Now, to get the clear idea of the point and the moment, we must have some idea of initial position and the final position. Now, if you have a line segment PQ, so the initial point P will have the x coordinate x and the Q will have the what? Coordinate x plus delta x. Similarly, in terms of time t, P will have the time coordinate t and Q will have the time coordinate t plus delta t. Now, this line segment PQ becoming a point when delta x tends to 0 as well as delta t tends to 0, because the PQ line segment becoming a point when Q is sufficiently close to P, as close as you can imagine. It means mathematically delta t tends to 0 and delta x tends to 0. So, to define the instantaneous velocity at a point P, for example, so it will be the average velocity delta x by delta t when limit delta t tends to 0. It is a limiting value. Delta t tends to 0 means sufficiently close to 0, not exactly equals to 0. And when delta t tends to 0, delta x also tends to 0, and then the quotient delta x by delta t must have a finite value. You see sample problem, then you can understand. So the instantaneous velocity we can mathematically express in this way: v equals to limit delta t tends to 0, delta x by delta t. It is an old math. In the new math, that is in calculus notation, it can be written as dx dt. Truly speaking, it is not dx by dt, it is dx dt. Actually, it is coming from an operation, ddt operation of x. In the example, I will explain. So ultimately, instantaneous velocity equals to what? In old math symbol, limit delta t tends to 0, delta x by delta t, that is an average velocity, limiting value of an average velocity at the point P, or we can say in the calculus notation dx dt. Now if you draw a graph, you see graph figure P031, that if you have the point PQ, then the V equals to delta x by delta t, that is the chord, the slope of the chord PQ, and when delta t and delta x tends to 0, the chord becoming tangent, and we have limit delta t tends to 0, delta x by delta t equals to slope of the tangent, yes, of the graph given in figure P03. Now you see sample problem 03. So how to find the instantaneous velocity? From sample problem you have more clear idea. Let us see. Suppose the motion of a particle moving along the x-axis is described by the law x equals to 5 meter per second square t square minus 40 meter. You see 5 has a dimension because 5 t square as well as 40 will have the dimension of meter. Accordingly, you can see 5 will have the dimension 5 meter per second square. Now we have to find the what is required? Find the instantaneous velocity at t is equal to 2 seconds. So try to understand that the time t is equal to 2 seconds. What is the mathematical meaning of this? This moment 2 seconds actually has the coordinate 2 seconds, and the another end will have the coordinate 2 seconds plus delta t. The moment 2 seconds means when delta t tends to 0. Be careful. A moment has a length. A point also has a length. So if you have a point, its left coordinate is one end is x, other end is x plus delta x. So what is the point? When delta x tends to 0. So length of the point delta x tends to 0 will give the what? Actually physical meaning of the point. So a point means, so if you consider one point P, another point Q, the line segment PQ becoming a point when Q is sufficiently close to P, as close as you can imagine. In the notation, P has the coordinate x, Q has the coordinate x plus delta x. So when delta x tends to 0, obviously Q is sufficiently close to P, and this gives the concept of point. So point has a length delta x tends to 0. Similarly, in terms of t also we can explain. The coordinate t for p is equal to t, and for q t plus delta t. When delta t tends to 0, q is sufficiently close to p, and then it becomes a moment at p, at time t, at the point p. Now you see the solution here. So the position at time t is equal to 2 seconds, just you put here, t is equal to 2 seconds whole square is equal to minus 20 meter. The position at time t is equal to 2 seconds plus delta t greater than 0, because time always goes on increasing, is. So we are going to find out the position at time t is equal to 2 seconds plus delta t. Why? Now finally we will put delta t tends to 0, so that we will have the instantaneous velocity at the moment t is equal to 2 seconds. Yes. So you see, so what is the final position? 5 meter per second square. Then put the value of t, 2 seconds plus delta t whole square minus 40 meter. Just to calculate, it will be ultimately minus 20 meter. This will be the final expression for x final. So what is the displacement during the time interval delta t? Delta x equals to x final minus x initial. Now put x final value and x minus value. We will have this one, and you note that when delta t tends to 0, you see delta x also tends to 0. Be careful, when delta t tends to 0, delta x bound to tends to 0, so that the line segment PQ becoming a point, and the moment yes corresponds to delta t tends to 0. So when delta t tends to 0, delta x also tends to 0. Otherwise, the quotient cannot be defined. So you see, the average velocity during the time interval is what? Delta x by delta t is equal to just dividing both sides by delta t not equals to 0. So we can divide both sides. So 20 meter per second equal plus 5 meter per second square delta t. Now we are going to find the instantaneous velocity at t is equal to 2 seconds. How? Now when delta t tends to 0, the moment will be 2 seconds, because the moment has one end 2 seconds, other end 2 seconds plus delta t. So what is the moment 2 seconds when delta t tends to 0? That we have set. Instantaneous velocity at t is equal to 2 seconds equals to limit delta t tends to 0, delta x by delta t. It's a limiting value, and you see, so what is delta x by delta t? Already given, it's 20 meter per second. This is already set. So when you see a small quantity like tends to 0 is connected to a finite quantity by plus sign or minus sign, then you can easily put 0 here. So ultimately it will be 20 meter per second, because with respect to 20 meter per second, it is negligibly small. So remember always, when you have a very, very small quantity, yes, connected by the large quantity, finite large quantity by plus sign and minus sign, then only this quantity can be written as 0. Not in the multiplied form, not in the quotient form. Be careful. Only a small quantity connected to a large quantity by plus sign, minus sign, then you can put this small tends to 0 equals to 0. So ultimately we will have plus 20 meter per second, and plus sign indicating the what? Positive direction. That is the increasing x, because when you move along the increasing x, delta x is positive and delta t also permanently positive. So delta x by delta t actually gives us the what? Direction. Gives the positive direction, means the particle is moving along the increasing x. The second method, calculus. Wait for calculus. In review 8 we have discussed calculus. After that you can realize the calculus concept. Similarly, SP04, you see exactly identical, we can move. 04, the motion of a particle moving along the x-axis is described by the law, x equals to 20 meter minus 4 meter per second square t square. So we are going to find the instantaneous velocity at t is equal to 4 seconds. First method, old math, the concept of limit. So position at t is equal to 4 seconds, x is equal to, just put t is equal to 4 seconds, so 20 meter minus 4 meter per second square, 4 second whole square is equal to minus 44 meter. Then the position at time t is equal to 4 second plus delta t, same. Always moment 4 second means what? One end 4 second, other end 4 second plus delta t. So the moment 4 second can be obtained if you set delta t tends to 0. Just like a point also, a point has one end x, other end x plus delta x. So when this becomes a point when delta x tends to 0. So be careful. A point has a length as well as a moment also has a length. Point has a length delta x where delta x tends to 0. Moment also has a length delta t where delta t tends to 0. So here also you see at the position at time t is equal to 4 seconds plus delta t, we will have what? You can write x final or you can write x plus delta x. Initial x I have written x. So final you can write another way x plus delta x. Now put the value of t 4 seconds plus delta t, simplify, ultimately you will have this one. Again you verify. When delta t tends to 0, bound to be you see delta x tends to 0. Bound to be always. So the quotient, yes, must tends to a finite value as per the law. Let us see what's the value. The average velocity during the time interval what? Dividing by delta t. So we will have this one. Now to get the instantaneous velocity, we must put delta t tends to 0. It is a limiting average value. So what is the instantaneous velocity? It is average velocity as the limit delta t tends to 0. So set the values here also same as before. This right quantity is what tends to 0 connected to left quantity by plus sign or minus sign. Left quantity is what? Large value, and the right quantity tends to 0 connected by plus sign or minus sign, in this case minus sign. So simply we can put this equals to 0. So minus 32 meter per second. And the negative sign indicating what? The particle is moving along the direction of decreasing x, because in this direction delta x is negative and delta t is permanently positive, you know. Second method after calculus you can realize.